And I'm just going to squeeze through. Okay, so let's have a look at aldehydes. Should be relatively familiar with aldehydes now. What do you know about aldehydes? Do you know where to find them? Find them on in that table on the formula sheets. And they're given the structure that, aren't they? So the aldehyde has the carbonyl group on the end of the molecule. And we've got some examples in your booklets. They are isomeric with ketones. What does that mean? Yeah, so same molecular formula. But different structure. What do you remember about the structure of ketones? Anything?
They're in the middle of the molecule.
Yeah, so for the ketones, have the carbonyl group but not on the and it's represented like that on your formula sheets as a generic form of a ketone. We have ethanol in our booklets, and our naming is the same in that we're still starting with the beginning of the name as if it were the alkane, and then we replace the ane with al to indicate that it's an aldehyde. And do you think we could make, is there a ketone isomer of ethanol? No, why not?
Because it wouldn't be in the middle.
It wouldn't be in the middle, it's not long enough. Propanone is the shortest ketone. Okay, so we have to have 3 carbons in a chain as our shortest ketone. So it still has that, our name, beginning part is as if it were the alkane, and then we change the ane ending to one to indicate that it's the ketone. So it's the one part that we're keeping for the ketone, and it's the beginning of the al there for the aldehyde. So if I wanted to make propanol, it would need to be that. Now, do I need to number this one? No, why not? It can only be on the one spot. It has to be on the end, and so we don't need to number that. Just say we had something else on there. Then what would I do if I have to name it? So it's propanol, but what is it? 3-bromo propanol. Okay, is that all right? That you're still using the same method that you used before. We must remember that we're always numbering from the functional group. From our last lesson when we were talking about our oxidation reactions, do you remember, can we oxidize our aldehydes? Is it a yes or a no?
You can.
A yes? And what do they oxidize to? The carboxylic acid. What about our ketones? Cannot oxidize. And so a common question would be, because these are isomers, that you're going to differentiate between two. You're given a molecular formula perhaps, and you're asked to say what the structure might be based on whether you can oxidize it or not. So you need to be able to remember that you can oxidize the aldehyde but not the ketone. And if we used acidified permanganate or acidified dichromate to oxidize, what would we be looking for in that experiment to know which one was which?
What it turned into, like if it turned into an aldehyde or a carboxylic acid.
Colour change.
A colour change, yeah. Colour change with our acidified permanganate or acidified dichromate is going to be the easy way to see if these reactions have occurred. But yes, we could then look at maybe reactions afterwards to confirm that. How can we make an aldehyde? What kind of alcohol? Okay, so that's an important part to include. It has to be primary alcohol. How can I make a ketone?
Yeah, you oxidize the secondary alcohol.
Okay, so that's what we know how to make them, and we know what reactions they can undergo, oxidation reactions. Now, the physical properties are quite similar. They are isomers, and what kind of intermolecular forces do they both have? What do we need for hydrogen bonding? Hydrogen's bonded to what? Oxygens or nitrogens? Do we have any hydrogens bonded to our oxygens? No. So we don't have hydrogen bonding. But what do we have? Dipole bonding. This is a dipole. This is a dipole. And so we are going to have dipole-dipole bonding as two adjacent molecules interact with each other. This is slightly negative. This is slightly positive. We're going to have some forces of attractions between adjacent molecules. Okay, so this is, and it's this part here that's the dipole-dipole bonding. Okay, this is just a dipole. And so we call it dipole-dipole bonding because we have to have a dipole on both molecules for them to interact with each other. Otherwise, this is the sound of one hand clapping. Right, so I've only done it here for my aldehyde, but the interactions are going to be the same for the ketones. And they are both going to therefore have higher melting and boiling points than their corresponding hydrocarbons. Where would they sit in relation to the alcohol? So if we had propanol or ethanol, what do we think the boiling point is going to be like? Which one's lower? Yeah, the aldehyde or the ketone will have a lower boiling point than the corresponding alcohol because the alcohol has hydrogen bonding. Yeah. So these forces of attraction, this is a greater attraction than corresponding hydrocarbon, but a lower attraction than corresponding alcohol. Okay, I think I'll stop there. Do you know what?